cosines. This is the law of cosines here. We've got 3 versions of the law of cosines. And you can copy all 3 of them down if you want. Or I usually only think of just that first one, but notice, like, if you have a lowercase a, you have a capital A over here at the end. Lowercase b, capital B over here at the end. Lowercase c, capital C over here at the end. So it follows the same pattern. You will get a formula sheet that I should copy for you, but on Friday, daycare closed early because they were out of power, so Henry was with me for the second half of the day. I did not get a lot of things done. He did do some artwork on the board. But I need to copy those formula sheets for you. So you do not have to have the law of cosines memorized. It is given to you on the formula sheet. You don't have to have law of sines memorized either, but most kids don't have any trouble with that. Cosines is a little bit tougher to memorize. So, law of cosines, the formula for law of cosines, I think looks really terrible. But in a lot of cases, law of cosines, I think, is even easier to use than the law of sines. So, it must be used whenever you have 2 sides in the included angle. So that would look like this if you knew this side was 5 and this side was 8. And then you knew this was 60 degrees in between those 2. So it almost looks like it's angle side, but the angle is between the 2 sides. So it is not, it's a side angle side triangle. So here is our first one that we're going to do. So I'll give you a second to copy that down. If we try to set up law of sines, we can't. Because if you try to do sine of 98 over A equals sine of, you'd have to use B or C over 12. You end up here with 2 variables. Got a variable here and a variable here. And you can't solve that equation whenever you've got 2 variables. So, law of cosines, even if you don't remember about the side angle side, if you try to set up law of sines, it's just not going to work. So, in this case, we've got side A is the side we're trying to find. So that means we're going to use that top rule that says A squared equals B squared plus C squared minus 2B C cosine of capital A. So we will not plug in anything for our A squared because we don't know what it is. It really doesn't matter which one's B and C, but since they're labeled here, I'm going to put my B is 12 and my C is 15. And then 2 times 12 times 15 cosine of 98 degrees. So, the good news about this is you can type every bit of this into the calculator at one time and it will do it correctly. There's no special parentheses or anything you really have to do. It's not that difficult to type in. So I'm going to type everything in. 12 squared plus 15 squared minus 2 times 12 times 15 times cosine of 98. And I got 419.102. Like this. And then we have to be really careful. That is not our answer because this is a squared equals that, so you have to square root both sides. So to get a, we're going to take the square root of this number. And that is going to give us 20.472. Okay, questions? Okay, I think these are pretty quick to do. Just do be careful about making sure you take that square root, because it would not make any sense in the world for this side to be 419. You got 12, 15, and 419. That's impossible. That can't actually happen, right? So make sure that whenever you check your answers, A is longer than these two, but it's not that much longer. It's 20.472. That seems reasonable for this. Okay. All right, questions? All right. No. No, you cannot. There are some problems that are only, so if you had two sides and the angle in between, then law of cosines is the only way you can solve it. If you have angle side, or if you have angle side, or if you've got two of the angles and only one side, then you have to use law of sines. So pretty much problems that we have done with law of sines, they cannot be solved using law of cosines, and problems we have done using law of cosines, they cannot be done using law of sines. You'll see whenever we do some solving triangles, like if I was wanting to do the next step of this problem, now that I know this side right here is 20.472, if I needed to find, like, let's say angle B, then I could set up law of sines to find angle B, to find the next part. But as far as finding that side A, that first step, you have to use law of cosines. Okay, for this next one, I'm going to let you guys just draw the picture. You don't have to copy all the words unless you just really want to. So, car A and car B leave the same point at the same time. Car A travels north on a straight road at 60 miles per hour. Car B travels 20 degrees south of east on a straight road at 45 miles per hour. After 2 hours, how far apart are the cars? So, I'm going to make a coordinate plane here. And the most logical starting point for these two cars right here is just to say they start right here in the middle. And this is north, this is south, this is west, this is east. And so car A travels north on a straight road at 60 miles per hour. So car A, it's going to go north. And car B travels 20 degrees south of east. So whenever you are reading that, 20 degrees south of east, this might be one of the first times you've really seen that sort of specifics whenever you talk about direction. Typically we'll talk about northeast, northwest, southeast. This is a very specific direction. So it's 20 degrees south of east. So east is your main direction, and you're going to the south of that 20 degrees. So 20 degrees to the south of east. It's going to look like this. And this is, let me label these. This is car A, and this is car B. So let's say car B has committed a crime, and they're making a getaway. Car A is the police car, and they're trying to chase this guy, but they've got their direction wrong. They've messed up pretty bad because they've gone 2 hours in the wrong direction. Let's say the helicopters are all around here. For whatever reason, they didn't see the car over here. We want to know how far it's going to be for the helicopter to fly back over here to where B is at. So they look on traffic cameras or something and they see, oh no, B actually went this direction. How far does our helicopter have to go to get over here to B? So first we have some angles, but we do not have any lengths of sides right now because it just gave us speeds. But if car A travels for 2 hours at 60 miles per hour, then Boone, how far did car A travel? For 2 hours, 60 miles per hour. 120. So this car has gone 120 miles. Okay? And then, Adam, what about car B? How far has it gone? 90. Good. Okay? And so we want to find this side right here. We've got one more problem before we can get started solving this triangle. I don't know this angle between the two sides right now. I know this part right here is 20, but that's not the whole angle. What would that whole angle be? It's going to be 110 because this part right here is 90. If you add the 20 to it, you've got 110 degrees. So for this, x is what you're trying to find. So you have x squared equals, it really does not matter which side you make, side A and side B. So I'm going to do 90, or B and C, however you want to label it. 90 squared plus 120 squared minus 2 times 90 times 120. And then it's going to be cosine of the angle that you have here, so 110. And I probably went way too fast setting that up because many of you may not have seen law of cosines before. Once you've used it a lot, it's pretty simple to set up. So here, that X, that was my A. That was my capital A right there. This is my B. This is my C. So we're just going to type this into the calculator. We will have 90 squared plus 120 squared is going to, or minus 2 times 90 times 120 cosine of 110. And so you get that huge number. That would not make any sense as your answer. You're not done. You've got to square root both sides. Whenever you do that, you got 172.80. Miles there, so about 173 miles. So this sort of stuff could definitely be used in tracking and looking for, could be criminals, could be, other stuff. If they actually are doing all this stuff for you, then you're probably a pretty high-profile criminal. You probably did something worse than just, a minor crime. Also, a lot of the things that we do have to be oversimplified because because this road right here probably doesn't run perfectly north the whole time. And this road right here is probably not perfectly 20 degrees south of east the whole time. And there's also other roads that you could turn off on, and so, of course, that makes things more complicated than this sort of simplified problem, but it gives you an idea of what could be done here. Okay, questions? All right. All right, here's our next one. Say that again. Oh, yeah, that should say equals. That's a typo. Let me fix that. There we go. I don't know if I did attendance. I don't think I did. I'll do that real quick. Nope. I'll put it right back up. Okay. Alright, these problems where you have only sides, they're a little bit tougher than the ones that we've done so far. So, in order to solve this triangle, you're going to have to find one of the angles, x, y, or z. It really does not matter at all which one you choose. So, Jade, which angle do you want to find, x, y, or z? Z. So let's say we're going to find z, and this is going to be the angle that we're going to look for. So, the law of cosines here, in this case, if we're finding z, then z squared would equal, I'm going to write it, you'll have x squared plus y squared minus 2xy cosine of capital Z. There. So we'll have z squared, so we'll have 22 squared equals 14 squared plus 19 squared minus 2 times 14 times 19 cosine of z And so to solve this, it's going to be a little bit different than what we were doing before. So we'll have 22 squared is going to give us 484 equals, you can go ahead and do 14 squared plus 19 squared, but do not add this stuff in there, because this stuff, 2 times 14 times 19, is multiplied by cosine z. So it has that variable with it, so you can't combine it. So you got to have 2 times 14 times 19. And that's going to give you 532. And whenever you do this, do not combine these two right here. This is like having 557 minus 532x. You can't combine them. They're not like terms. So you've got to solve for that z right there. So you'll have to subtract 557. So 484 minus 557. It's going to give you negative 73 equals negative 532 cosine z. We can divide by negative 532. So we divide by negative 532. We're going to get 0.137218 equals cosine of z. And then we have to do cosine inverse of that number, and so we get that z equals 82.113. And I'm going to go ahead on my calculator and store that as the letter z. So save. Okay, questions? I really like law of cosines when it's the other problems. I'd rather do law of sines than these problems. Also, for this one, it asks us to solve the triangle. So that means we've just found 82.113 here. But we've also got to find x and angle x and angle y. So this is the point where it's okay if you want to, you could do law of cosines again, and that would be fine. But you also could use law of sines in this case. So I think law of sines is a little bit quicker. So I'm going to say sine of 82.113 over 22 equals, Sadie, which one do you want to find, x or y? Y. So we'll do sine of y over 19, and we will cross multiply. We'll have 19 sine of 82.113 equals 22 sine y. We would have to divide by 22. So 19. Since I stored my z, I'm going to use that letter z there instead of the number. That way I don't round at all. So 0.855467. And if I do sine inverse of that number, then I get that my y equals 58.811 degrees. Now, we would, because I did use law of sines, 58.811 degrees. I would want to check ambiguous case. It is very rare that it happens, but it occasionally does. So if I do 180 minus this answer, I get 121 and 82. That's too big, so it's not an ambiguous case. It's very rare that you'll get, if you get ambiguous case on one of these, then you need to go back and just use law of cosines for that, so that you know which one it is. The good thing about law of cosines is there is no ambiguous case for law of cosines, so you will know what answer that you will get. It's very rare that you'll get this, but occasionally it will happen. And then, so the last one, thank goodness we can just do 180 minus 82.113 minus 58.811. And that's going to give us 39.067. So angle X is going to be 39.0. I'm sorry, I said that backwards. 076 degrees. So for our answer, we had this 82, the 58, and the 39. Questions? All right, that is it for the notes. So you're going to have a little bit of time to work on your homework, which is good. Let me tell you what you'll have. We are going to do page 331, 11 through 16, '25, and 27. Let me give you a little hint on 27. That picture is a little bit misleading because it gives you the view of the field at an angle. If we're looking at a baseball field from above, and all the way out to the center field fence, this length right here, is 400 feet. And we know the length from home plate to the base is 90 feet. And so somebody has the ball way out here right at the fence, and we want to know how far they've got to throw it to get back to first base. I feel like it's impossible for them to get somebody out at first base. In this case, I think third base would have been a more realistic option. But we want to know how far they've got to throw that ball. So they don't give you any angles. They're expecting you to find out the angle based on something you know about baseball. Any ideas on any of those angles that you could know? Okay, so my picture's not drawn very well, but the infield there sometimes is called the diamond, but I guess it is a diamond, but it's also a square. So that means this angle right here, this is a 90-degree angle. So if we're going from home plate directly to center field, then that's going to split that angle right there in half. So this angle right here is 45 degrees. And so then that gives you the triangle that you're going to look at. It's even more kind of misleading whenever you look at the picture because they're showing you the view of the field from like an angle, and it doesn't look quite as much like a 45-degree angle to me there. go ahead and get to work on that. You got about 15 minutes.